This course introduces stepping motor control technology as the basics of motor control. A stepping motor rotates synchronously with input pulse signals. A step angle is a rotary angle for one pulse. An input pulse signal is controlled so that it stops at the desired angle. The rotating speed of the motor depends on the pulse frequency given to the motor. The rotary speed of the motor decreases when the frequency of the pulse signal is lowered. On the other hand, the rotary speed of the motor increases when the frequency of the pulse signal becomes high. The stepping does not use a sensor and can stop the motor at the right position. The stepping motor determines rotary speed and performs control to stop only with the pulse signal, and therefore, the positioning detection sensors, such as an encoder, are unnecessary. One of the disadvantages of stepping motors is out of step. At a sudden change or at high-speed rotation, out of step perhaps will occur, comparing to DC and BLDC motors. The out of step means that the rotor cannot follow supplied pulse signals, and rotating speed cannot be controlled. Open loop control is a feature of the stepping motor. In the DC or BLDC motor, it is necessary to feed back the positional information of the motor to a microcomputer. This system is closed loop control. A stepping motor rotates synchronously with the pulse signals. Normally, motor position information is not required, therefore a feedback circuit is unnecessary. This is called open loop control. However, to avoid out of step, there may be cases when closed loop control is implemented, using a position detection sensor. Stepping motor are categorized into unipolar and bipolar types, depending on the difference of winding structure. In the unipolar type, the winding current flows unidirectionally. In the bipolar type, the winding current flows bidirectionally. Whereas the unipolar type can have the number of driving elements, compared to the bipolar type, a higher voltage resistant circuit is required, because this type is affected by counter-electromotive forces. Whereas the bipolar type has twice as many driving elements as the unipolar type, it can be driven with the lower voltage resistant circuit, because it is unaffected by counter-electromotive forces. Stepping motors are categorized into three types according to the type of rotor: a variable reluctance type, a permanent magnet type, and a hybrid type. Each type comprises a gear-like rotor or a permanent magnet rotor. They differ in terms of torque performance and step angle accuracy. The number of stators in a stepping motor is mostly 2 or 5. This matches the number of phases. Therefore, they are called 2-phase and 5-phase motors. Whereas 2-phase motors are commonplace in applications requiring highly accurate position control, 5-phase motors are used. One of the most common motor types is the 2-phase 100-pole hybrid, with the step angle of 1.8 degrees.